Okay, this is Chemistry Unit 4. This is the third video. We're picking up on page 3, and here we're talking about the atomic mass number. On the previous page, we went over atomic symbol, atomic number, and mass number. Here we're talking about the atomic mass number. The atomic mass number shows the number of protons and neutrons. But this number is rarely a whole number, and it tends to be a decimal. So as we just learned, protons are always present in whole numbers. So if the atomic mass is a decimal, do we have fractions of neutrons? So look at your periodic table. Find carbon, it's at the top, it's to the right of the middle. Carbon has 6 protons, and its atomic mass number is listed. The one I'm looking at says 12.011. If you're looking at a different one, it might say 12.0107, or it might be a longer number. They're all rounded. Atomic mass is 12.011. So, does that mean that carbon has 6.011 neutrons? The answer is no. We don't have fractions of neutrons. It's not possible. They have to be in whole numbers. So neutrons are always here in whole numbers, and the fractions just don't exist. So then why is it a decimal? Why is the atomic mass a decimal? Here's the reason. The atomic mass is an average. It's an average of all the isotopes that exist for a particular element. And it's not just a regular average, it is a weighted average. So all the isotopes that exist and how common is that isotope. But it's an average. So think about a basketball game. If I make 4 shots for 2 points each, there's 8 points. And then I hit a 3-pointer, I have scored 11 points on 5 baskets. My average number of points per shot is 2.2. But is it possible? Can I make any one basket that's actually worth 2.2 points? No, it's not possible. Any basket that we make is worth 1 point, 2 points, or 3 points, all whole numbers. No shot is worth a fraction of a point. Just like there's no fractions of neutrons, there's no fractions of protons. So carbon has an atomic mass number that we get from the periodic table, 12.011. Most carbon atoms have 12 protons and neutrons. This would be the mass number. The mass number is 12. We would refer to a carbon with a mass number of 12 as, you could write it as carbon 12, like this. You could write it as this number, carbon mass number is 12, atomic number is 6. There are other carbon atoms, so there's mass number of 13. That's carbon 13, or you could write it like this. Could be carbon 14. Carbon 14 is your radiocarbon dating. Remember, it's the one that we use to figure out how old is this fossil or plant that we dug up out of the ground that's very old. So find the atomic mass of this carbon based on the following data. Here's my 3 isotopes of carbon, and the occurrence is how often we see it, or how many of all the carbons in the world are this carbon. So carbon 12, which has a mass number of 12, accounts for 99.0% of all carbon in the world. Carbon 13 accounts for 0.9% of all carbon, and carbon 14, 0.1% of all carbon. Now, a quick review on percentages. A percentage is showing us part of a whole. This is 99%. What this actually means is 0.990. So this is the number out of 100. This is the number expressed as a decimal between 0 and 1. This one, 0.9%, is 0.009, or 9 thousandths. This 1.1% is 0.001, 1/1000th. Whenever you do calculations with percentages, we need to use these numbers expressed as decimals. The percentages are going to give us an answer that is much larger than it's supposed to be. It's going to be 100 times bigger than it should. So given the fact that we have 3 isotopes, I know their mass numbers, and I know how often each one shows up in the world, we can figure out the actual atomic mass. So here's what we do. We take the mass number times its occurrence. So I find that carbon 12, I have 11.88. We're going to add these together in a minute. We have 13, which is 0.009, which is 0.117. And carbon 14.001, this is 0.014. And these 3 numbers, I'm going to total them up, I'm going to add them together. So, quick note first, I am completely ignoring significant figures in all of this because I have some numbers with 1 significant figure, some with 3, some with 2. And when I add these together, again, I'm just going to ignore it. The reason I'm doing that is because all of these numbers were rounded already. And so I'm just going to go ahead and go through this. 7 plus 4, there's 1. Carry the 1, there's 9, 10, 11. There's 10, so that's 0. There's 2, and there's 1. So we find the atomic mass of carbon is 12.011. Does this agree with the periodic table? Look at your periodic table. Probably says 12.011, 12.0107, which rounds to this number, something close. One place that students use this type of average is usually in December and May, when students are trying to figure out what their final grades are going to be for the semester. Or if a student wants to know, I want a B for the semester, what do I have to get on the final? And the final grade calculation is a weighted average. It's basically what score did you get in the first 9 weeks? The occurrence is 3/7. What score did you get in the second 9 weeks? The occurrence is 3/7. What did you get on the final? Its occurrence is 1/7. You add those 3 numbers together, and it tells you your weighted grade for the semester. We're looking at neon this time. So neon, and we have neon 20, neon 21, neon 22. 10 protons. So the mass number of the first one is 20, and it shows up 90.48% of the time. So let's change this to a decimal first, 0.9048. Then we have neon 21. Mass number is 21, and it shows up 0.3% of the time, which is 0.003. We have neon 22, and it shows up 9.2% of the time, expressed as a decimal, 0.092. So we're going to do the same thing that we did on the one above. I'm going to draw a line to separate these two. Same thing that we did above. So we're going to multiply the mass number times the decimal of how often we see it. 20 times 0.9048. This one equals 18.096. 21 times 0.003. This one is 0.063. Neon 22 shows up 0.092 as the occurrence, and that is 2.024. Add them together, we've got 10, 13, we've got 10, 16, 18, 1, so we've got 20.183. Take a look at your periodic table. What does it say? The one that I'm looking at on the wall says 20.1797. And it all depends on how you round it, these numbers, and where you get your data. 20.18 is an acceptable number. 20.2, 20.1797. All of these numbers are close enough that this one looks pretty good.